Can you imagine using a laser beam to take you to Mars? I know it sounds insane, but might soon become a reality. At present, it takes 6 to 9 months to reach Mars from Earth. Even with revolutionary techniques like nuclear thermal propulsion or nuclear electric propulsion, it will still take 100 days to reach Mars. But now, researchers have found the fastest way to travel to the red planet with the aid of lasers. They call this method laser propulsion, and it is believed that it can take us to our neighboring world in just 45 days. But what exactly is laser propulsion? How can it take us to Mars within a month and a half? And most importantly, what are the challenges involved in turning this idea into reality? Directed propulsion, also known as beam-powered propulsion, has been a hot research topic for the past few years. In these methods, a beam of energy, typically microwaves or a laser, is used to propel a spacecraft remotely. A laser is nothing but a focused and coherent beam of powerful photons. So when a stream of photons falls onto the reflectors of a spacecraft, they impart the spacecraft enough energy to travel through space, thereby creating a light sail. This situation can be considered analogous, maybe not literally, to a sailing boat, where the sail is being blown and directed by the wind. In this manner, the laser beam eliminates the need for the spacecraft to carry any propellant with them, thereby lowering their mass in a significant manner, and on the contrary, increasing their speed. The famous Starlight program, which aims for interstellar travel in the future, especially a trip to our neighboring star system, Alpha Centauri, is also based on this propulsion method. Not only this, but projects like Starshot and Dragonfly also aim to employ a gigawatt power laser array to accelerate a light sail and a small spacecraft to reach nearby star systems. Undoubtedly, the ideas of interstellar missions based on laser propulsion have existed for years. But it's the first time that similar technology has been thought to be used for interplanetary travel. Precisely speaking, researchers working in this regimen have proposed to use intense laser flux on the spacecraft to directly heat the fuel, which is hydrogen in this case. This would eventually allow the spacecraft to accelerate rapidly while it is still near Earth, and due to this, even the laser won't be needed to be focused far into space. After the initial stage is completed and the spacecraft has accelerated, the main vehicle is set on its journey to Mars. The same laser-powered rocket engine can be used to bring the booster back into Earth orbit, hence saving the resources once again. It wouldn't be wrong to say that the concept of laser propulsion is akin to a nuclear thermal propulsion system, where nuclear reactions play their part and the heat is transferred from the reactor to a liquid propellant. Furthermore, the heat converts the liquid into a gas, which finally expands through a nozzle to provide thrust and propel the spacecraft. However, the only difference is that a laser has taken the place of a nuclear reactor. Although this concept sounds extremely exciting, realizing it in reality is not a piece of cake. Several factors and requirements need to be taken care of. First of all, we need arrays of fiber optic lasers to focus the laser beam when it arrives at the spacecraft into the heating chamber. Then, high-temperature materials are required to allow the spacecraft to break against the Martian atmosphere when it arrives there. In addition to this, a highly efficient reflector is also needed to sustain a greater laser power per unit area than a regular photovoltaic panel. Together, all these elements can enable a rocket to carry out extensively fast transits to Mars. Besides saving time, such a quick trip to Mars has numerous advantages. This would provide a solution to several known problems, essentially the ones related to prolonged exposure to radiation and microgravity. Reaching Mars in 6 weeks was previously thought to be conceivable only with the help of nuclear-powered rockets. However, such spacecraft pose a greater radiation hazard, so laser propulsion can be a pretty good and safe alternative to this. There is no doubt regarding the potential and advantages of laser propulsion, but with a highly ambitious idea like this, many challenges need to be overcome. And amongst all the challenges, the laser heating chamber is likely the most significant one. It still needs to be figured out how we can store hydrogen gas, heated to temperatures greater than 10,000 kelvins in a chamber, by simultaneously keeping the chamber's walls cool. Although the models suggested are feasible, we haven't built the 100 megawatt lasers needed to achieve the purpose yet. So experimental testing at full scale is not possible at present. Besides this, a rapid transit system also needs to be set up between Earth and Mars. This should include a gateway-like space station in orbit of Mars, as well as a laser array to decelerate incoming spacecraft. If everything goes well, laser technology can be a real game changer in the future that can change our understanding of interplanetary travel forever. What are your views about this mode of travel?